In this video, I want to take some time and review confidence intervals. So confidence intervals, we've talked about a number of different types. Building an interval for mean, a sample proportion, a difference in means, a difference in proportion, and a matched pair. So in every one of these cases, you gather your information from a sample, and then you try to make some inference about the population. So the state is, I will build a whatever confidence you want, confidence interval for the population mean, population proportion, difference in population means, difference in population proportions, or this matched pair, the difference in before and after that population. That difference is sometimes called effect size. So again, what I wrote up here is that this is what you gathered, and then you're building the interval for the population parameter. Okay, so the plan step. Remember, this is where you write down your conditions. Every single one of them has the simple random sample. We want all of them to have well collected data. The difference in means and proportions, the two samples should be independent of one another. And I give you a kind of a quick AP question that they like to ask is, let's say you took a sample of 100 people and you found 40 that had an opinion of yes, 50 that had an opinion of no, and 10 that had no opinion. And they said, could you build a confidence interval for the difference in the proportion of yes and no's? And the answer is no. That's one sample of 100 people. So you would build a one proportion interval for the proportion of just yeses or just nos, but you couldn't do a difference because they weren't independent samples. Independent samples is, I asked 100 men and 100 women, 50 said yes, 40 said, compare the two, okay? Other conditions. Well, another condition that every single one of them has, if you remember, the sample size must be less than or equal to 1/10 the population size, and that is true for all of them. Okay. Conditions for sample means. Well, remember, we like to do the sample size should be bigger than 30, and that's true of any time we're dealing with means. Okay. If they're not, then we have to do some kind of graphical check. Usually it's a box plot. Also recall you could be given information about the original parent population. Like you could be told, well, the original population was normal. But if not, you make a box plot of your sample and you verify that it's fairly symmetric and there are no outliers. Okay. Now, for sample proportions, we have a little bit different checks here, and that is that the sample size times the proportion has to be bigger than 10, and n times 1 minus p. And I should mention, when you have two sample means or two sample proportions, you must do this check for both. You have to ensure that both samples are bigger than 30, or that both samples and proportions fulfill that. Okay? Now, just as a reminder, this first condition for all of them, this makes sure that we haven't asked so many people, sampled so many, that there is no variability. That's what that's for. The second condition ensures that we did actually collect enough data to use the T or Z in the case of proportions. So it really is a two-sided thing. We need to make sure that we have variability, but we also need to ensure that our sample was large enough. Okay? Now the do portion of this should always be done in the calculator. And then we just write down, you do a T interval here. You do a 1 proportion Z interval here. You do a 2 sample T here, T interval. You do a 2 sample proportion, and just again it's Z interval. I'll write interval here. And for a matched pair, that actually is a t-interval. And I'm just going to make a little note here as a reminder. Remember that you condense, that's list 3, down to one set of data. And I'm writing that down. That was kind of the way we would do it on our calculator originally, is we said, well, what's the difference? And again, that's often called the effect size. Like, what's the difference between those two? We condense down to one set of data. So in a two sample, we really do have two independent samples, and we're doing an interval for their difference. But in a matched pair, we're really making our interval around the difference between the two lists. Okay, and kind of that idea of a before and after. Now, the final part of this, to conclude, you say, well, I'm 95% or I'm whatever percent confident that the interval from blank to blank captures the population and the parameter. So again, kind of going back to what were we doing? We collected these sample things in order to make some inference about the population. So you're confident that the interval from blank to blank captures the population mean, or the population proportion, or the difference in population means, or the difference in population proportions, or the population effect size. All right, so this is all stuff having to do with confidence intervals, and I would urge you to kind of look back through your calculator, make sure you know where everything is. But let's also talk about confidence level. So please remember that confidence interval is we actually calculated an interval, and we're saying between here and here we're confident we've captured the parameter. A confidence level has to do more with kind of the methodology, and it says if you did this process over and over again, then whatever percent you set it at, 95 or 99 or whatever, of the resulting intervals would capture that parameter. So there's no mention here of the actual interval, because obviously if I had a classroom of 20 students and I said, okay, all of you go out and repeat the process. All of you go out, sample, and make your own interval. All 20 students are going to get different intervals. But of those 20, 19 should capture the real population parameter, 95% of them. So even though they have different intervals, 19 or 95% of the 20 students, they should get the parameter. So often on the AP exam, when level is asked about, on multiple choice, it'll start by giving you some, 95% of the intervals will be from this number to this number. We need to recognize that the intervals will all, in likelihood, be different, but they should all accomplish the task of capturing the parameter. So you should never be mentioning actual interval values, just recognizing that our method should work 95% of the time.